So quick review of what we left off with. We defined power. We said power was the rate at which work is done. It's how fast you're converting energy. It's tiredness. If you're getting tired, it's not because you're using up energy, it's because you're using up energy at a fast rate. At a fast rate. We define power as work over time. Scalar divided by scalar, which means power is also a scalar. The units for power are joules per second, but we've given joules per second a special name. Power is measured in what? Watts. Okay? We talked a little bit about horsepower. If I ask you a horsepower question on the test, I'll give you the conversion factor, but to be perfectly honest, I don't think I'll ask you a horsepower question on the test. I'm a metric guy. I wish the US would see the light and finally go metric. We also did say there was, and this is not on your formula sheet, hidden inside power is work over time. Because, Rob, work is force times distance, it's also two other things, but one of its definitions was force times distance. You have a hidden distance over time. Actually, power is also force times constant speed. F times V. How do you know when to use that? If they say find the power and they give you a force and a speed. Then we talked about efficiency. We said efficiency was power out divided by power in times 100%, or energy out divided by energy in times 100%, or work out divided by work in times 100%. You know what? Actually, that's not what I said. I said, okay, Rafi, make sure the units match. Make sure it's power over power, or joules over watts over watts, or joules over joules. And it's always going to be the smaller number on top, because you can't be more than 100% efficient. Sorry. I went on a little rant about light bulbs, and then we started looking at some questions. I think we skipped example 6, which was a lawnmower. We did example 7, which was a lawnmower. This was my pause here, right? We had finished part A. We found the rate at which heat was generated. Oh, had we found the rate at which heat was generated? I think we just found the time. This was a really, really nasty question. This is tougher than I'm going to ask you on your test. This also won't be on your test because, Nate, I told you for this unit, I'm not going to hammer you with components. What I did say was, I'll do some component questions in the homework and in the notes. So here was a component question in the homework and in the notes. We drew a little picture. They wanted to find the rate at which heat, as soon as they say rate, what we're talking about, if we're talking about the rate at which heat energy is created, that's power from heat. So we said it's going to be the work done by heat divided by time. It's going to be the force of friction times distance, force times distance divided by time. We did a free body diagram. We got the force of friction. The problem was they didn't give us the distance. So we said, they didn't give us the time. We said, okay, they told me the distance. I know VI. We used winner minus loser to find A, and we found time was that. And after all that, finally, we can say, holy smokes, the amount of power is going to be 56.837. There's the force of friction. Times the distance, which was 30, divided by the time, which was 10.49. How many watts did we lose to heat? Not of energy, but of power. 56.837 times 30 divided by 10.49. And did I say the answer was 163? 162 joules per second. I got 162.5. Probably depending on how many digits you carry, I'm going to call it 163 watts. 163 watts. Mm-hmm. I don't know. What did I say? Did I say this one would be on the test? Why not? Told you I'm not going to hit you with components. Okay. But we can handle it. It's doable. Example 8. This one is a better illustration of what I might expect you to handle on a test, Rafi. This is going to have, if I'm glancing at this, I think power, efficiency, and the whole schmear in one nice question. And it's a stair climber, so most of you have seen or been on a stair climber. So on a stair climber at the gym, a 75-kilogram person lifts their center of mass up 22 centimeters with each step. We're actually going to change the numbers because I've noticed this same question appears in your homework. Apparently, I forgot to change the numbers when I was cutting and pasting. So instead of 75, Let's make this person 65 kilograms. So A-Ling, change that to 65 kilograms. And instead of 22 centimeters, let's make it 25 centimeters. And instead of 18% efficient, let's make them 16% efficient. I'll leave the rest the same. So it says at a stair climber at the gym, a 65 kilogram person lifts their center of mass 25 centimeters with each step. If they take 360 steps in 6 minutes and their muscles are 16% efficient, then find the rate at which the rate at which the person does the work, power. How is power defined? What's the power equation? Power is what? Work over time. Now, in terms of the time, I think I got that. It's 6 minutes. I got to be careful. 6 minutes, I better convert that to seconds. It's 360 seconds. Which work, when you use a stair climber, what force are you working against? So it's going to be mgh. That's the work done against gravity. It's going to be 65 times 9.8. Now, what's their total height? Well, what's each step? And how many steps does this person do? So I think that's the same as climbing it straight up in a continuous line. It's just you're not going anywhere with a stair climber. I think we can say the height is 360 steps times 0.25. And that's going to be divided by 360. If you've ever ridden an exercise bike or done a stair climber or used any modern electric fitness machine, they will have a setting often where they can show you how much power you're generating. And sometimes they'll have it in watts. Usually they have it in how many calories per second or per minute you're burning, because calories is actually the food unit of energy. What do you get? 65 times 9.8 times 3. I guess technically the 360s would cancel. I could maybe even do this in my head, but I'll wimp out. 65 times 9.8 times 0.25. 159 watts. B says, find the rate at which the person uses food energy. Okay. We have to use efficiency here. How much power are we getting out? Well, 159.25 watts. What this question wants me to find out is how much power did he use up in food? In other words, Shaq, this question wants me to find power in. But they did give me the efficiency. How efficient are these person's muscles? I'll change it to a decimal. So my equation here is going to be, well, efficiency is power out divided by power in, times 100%, but Rob, I just changed the percentage back to a decimal so I can skip that step. Remember your Math 8 way back in the day. I guess power in, because this is technically 1 fraction equals 1 fraction, stuff moves diagonally, is going to be the power out divided by the efficiency. It's going to be 159.25 divided by 0.16. And I get 995. Where is the rest of that power going when you exercise? Okay, now got to be careful because power is watts, but in terms of, every second you're burning 995 joules of energy. Only 159 joules of energy are going into climbing the stairs. Where is the rest of the energy going? Lots of heat. Your body temperature definitely increases. But even things like, your heart muscles going faster, that takes some energy. The blood is being pumped faster. That's a force over a given distance now, and it's using more because you're pumping it faster. So there's absolutely, there's lots of ways where your body is using the food energy. Hey, this is why exercise is good for you. Multiple benefits. So I had already assigned 1, 2, 3, and 7, and 9. So you can now try, you can add number 10. Okay. And I'm not going to give 11. It's kind of cool, but meh. Oh, and 14, I think 14 is going to be kind of similar to the stair climber in that you have your average height, but what you got to think about is what's the mass? 60 people times 60 kilograms. What's the time? How many seconds elapse here? Where'd you get the 60 from? It says per what? They gave you the time as an English word, so it's going to be in terms of power over 60. Okay. Mickey, you had a question from the homework here or not?
Yeah,
number 9.
Number 9? Or 9B.
9B? Yeah. Okay. 9B is from the last unit. Did you dulp?
Yeah.
Okay, I'm going to dulp. There's my ramp. Did you do a free body diagram? Okay, I'm going to do a free body diagram. So here is the piano. What are the forces acting on it? Get the obvious one. Yep. What else? Oh, yeah. Friction? I know not.
No.
Right, frictionless. Now, there has to be one more. Oh, you know what? Here's the force that they want me to find. This is the applied force. The person pushing. And here's the key phrase. Can you read me that? It looks like I crossed it out. Here's the key phrase. What's the key phrase there? What that means is your acceleration is equal to what? Sorry? 0. I won't stop here. What would I do now with my free body diagram? Yes, I'd components. That's why it's from last unit. Here's mg perpendicular. Here's mg parallel. Folks, if we're going at a constant speed up the ramp, can you tell me what two forces must be identical, must be the same size? I'll give you a hint. One of them is F applied, the one I'm trying to find. What does it have to be the same size as? Yes. So the first thing I would say is this. Although it wants me to find F applied, really what I'm going to find is mg 2 lines is sine. Is that okay? Do I know m? Do I know g? Do I know the angle? No. Dulp again. Because you know what they told me, Mickey? They told me how long the ramp is. How long is the ramp? And how long is the vertical side, the height? Could I find the angle here from those measurements by going, I think it's going to be shift sine? And then I can crunch the numbers. That actually would be a nice little mini curveball question for the last unit where I don't give you an angle, but I give you the lengths. Now, by the way, what this question also wants you to realize is if I wanted to find how much work was being done, One way to find how much work, because energy is a scalar, I could go MGH. I could go 250 times 9.8 times the height. I'm doing 3,675 joules of work. Another way would be to go, look up, force times distance along the ramp. What's the force along the ramp? mg sine theta. So it's going to be, first of all, let me find theta. It's going to be shift sine of 1.5 divided by 8. The angle ends up being 10.8 degrees. So if I go 250 times 9.8 times the sine of, I'll put the answer button there, times that distance, which is 8. If I find force times distance along the ramp, I should get the same answer as mgh straight up. Why? Energy is a scalar, and sure enough, I do. So there's, again, it's confirming that, oh, energy is a scalar. Is that okay? That's a neat question. I don't know if I'm saying I like, well, no, it's got components, so I don't like that question for this next test. But I'm almost thinking about next year putting one like this on the forces as a multiple choice and a little curveball. Any others? Then let's finish off the unit, lesson 4, which is short, which could actually go anywhere. So lesson 4, which really I could stick anywhere. In fact, I used to do this at the beginning of the year, and then I thought, well, I stuck it in this unit because it's pretty short otherwise. Graphing tricks. Rob, for the rest of this year, in your homework, on quizzes, or on tests, I may give you a graph that you've never seen before and expect you to analyze it, either by telling me what the slope means or by telling me what the area under the graph means. Now, you can memorize all, I think there's about 80 different graphs, or you can learn the tricks of the trade. So you ready? First of all, if we have two quantities that behave in the following manner, y is 0 and x is 0, so they go through 0, 0. And as x gets bigger, y gets bigger. We say that they are directly proportional. Or we say y varies directly as x. If x gets twice as big, y gets twice as big. If x gets 3 times as big, y gets 3 times as big. If x is 0, y is 0. We write y, and there's a symbol for is proportional to, and it's a fish. It's actually a Greek letter, gamma, but looks like that. X. That's red. Y is proportional to x. Or if I want to turn it into an equation, I might need to put a constant in front of the x. For some reason, we use letter K for constant. Why? It's from German. The word constant in German starts with a K. Where K is called the constant of proportionality. You don't need to know this part. I'm giving you the setup, though. So that there, I'm not going to ask you, oh, what's the constant of proportionality? I'm not. What I am saying, Shaq, is you've been doing this without realizing it most of your math and physics careers. As an example, here's a graph. You didn't call it, don't write this down. In Math 10, you didn't call it that, don't write that down, don't write that down. You called it this. Except, what did I say don't write that down yet either. What did I say the y-intercept was if we're directly proportional? What do we go through? What did I say up here? What do we go through? 0, 0. So what will b be? Really, it's that, but in physics, it's traditional, instead of using an m for slope, to put a constant there. But understand, it's the same kind of an idea. It's really slope-intercept form. The slope of this graph is the constant of proportionality Jenny, I'm not going to ask you that. Instead, here's what you've already been doing without realizing it. Here is a distance versus time graph. What's the slope of a distance versus time graph? Velocity. That's why I have written up here as a little equation, d equals vt. Now, here is the trick I want to show you. Grayson, let's suppose I give you a graph and I say, hey, tell me what the slope means, and you blank. I don't remember. To figure out what the slope means, you can write this down. What's the little rhyme you remember from Math 10? Slope is what over what? Okay, you all remember that. Rise is the y-axis, Naomi. It's the rise is the highs, is the heights. In fact, I had a math teacher that actually taught it to us this way. To emphasize, this was the y coordinate. I thought that was kind of clever. I may do that when I teach Math 10 next time. But here's what I want you to notice then. What's the rise, the y-axis? What are the units on the y-axis? Instead of looking at the numbers, if I want to figure out what the slope means, I look at the units. What are the units on the x-axis? And then I would zoom out and I would say, hey, Shaq, what do I measure in meters per second? Velocity. You know what? The slope of a position or a distance time graph is the velocity. I actually don't memorize that. I derive it. Or if I couldn't figure it out from the units, I could also try dividing the variables and maybe I'll recognize the equation. D over T, maybe that's on my formula sheet somewhere. So what's the slope of this graph? Velocity. Velocity. If they ever ask me to talk about the slope of something, I'll divide the y units over the x units. Maybe I'll recognize that. Or I'll divide the y variable over the x variable. Maybe I'll recognize that. As an example, supposing you saw a graph that looked like this. And on the y-axis, we were measuring energy. And on the x-axis, we were measuring time. And you had a graph like that. What's the slope? Power. How'd you figure that out? Joules per second. Joules per second. Don't memorize that graph. Derive what the slope means. Think about how many different 2 and 3 variable little equations that we have. I can make graphs for all of those if I want to. No, don't memorize them. If it's the slope, Grayson, divide either the units or the variables. If I couldn't figure it out from joules per second, I might have said energy over time. Oh, energy, work over time. Work over time, that's right on my formula sheet. If you don't go through 0, 0, but when x gets bigger, y gets bigger, we say there is an indirect proportion. And we write y is proportional to kx plus b, and that in math turns into y equals mx plus b. It's good old slope-intercept form. So here is a graph. I'm graphing velocity, it looks like, on the y-axis. I think that's what v means in meters per second. I'm graphing time on the x-axis. What's the slope as a number? Well, goes through there, and I think Mr. Dueck, when he was making this up, was trying very hard to make it go through 10,6. That's why he stuck those numbers on there. So what's the rise? Don't say 6, because it's not. 3 over, okay, the slope. What does the slope mean? Well, what's on the y-axis as units, Shaq? What's on the x-axis as units, Shaq? Hey, what's meters per second per second? Meters per second squared, which is what? So, oh, you know what? That's the acceleration. So a good question, multiple choice, would be, hey, tell me what the slope of this means. In fact, you know what? On the provincials and on your final, the second last question was always, here's some graph you've never seen. Tell me what the slope means. Find the slope. They gave you 1 mark for going rise over run and getting a magnitude. And then part B was, tell me what the slope means. Or, you know what? Part B, a good part B, Naomi, would be, instead of saying find the slope, here's the slope. Part B, if the mass is 3 kilograms, what's the net force? And people would freak out. But wait a minute. Force is mass times acceleration. They gave you the acceleration. It's 0.3. They would ask you to do something with the slope. By the way, what's the y-intercept? What comma what? 0, 3. What does the y-intercept mean on this particular graph? I think it's VI, right? At time 0, you were going 3 meters per second. Zach, I've lied. On about half the questions when they gave you a graph, they said, tell me something about the slope. The other half, they asked about the area. So I have written down here, hey, what would the area here be? Don't memorize it. How did we find the slope? We went rise over run. How do I find an area? No matter what the shape is, even this weird funky one, in every area, I multiply, whether it's length times width or base times height, yes, divided by 2. But no matter what, I times. So if you want me to interpret an area, I'm going to multiply the y times the x. You know what? That looks like y, x, x. I'll use the dot for times. Either I'll multiply the variables or the units. Shaq, what did you say the units were on the y-axis? The units on the y-axis? No, the units on the y-axis? Times. What did you say the units were on the x-axis? It looks like when I multiply, I have a seconds on the bottom, I have a seconds on the top. What's going to happen to those seconds? Anyone? Cancel. What units are left behind? Oh, what is the area underneath a velocity versus time graph have to be? What do I measure in meters? The area under a velocity versus time graph has to be that. Has to be. Must be. It must be. If you give me a slope and you say, tell me something about it, Nate, I'll divide the units or I'll divide the variables. If you give me an area and say, tell me something about it, I'll times the units or times the variables. And 99% of the time, Rob, you'll be able to figure it out. We will be dealing sometimes with some curves. So if as x gets bigger, y gets smaller, we say y varies inversely as x. As an equation, y equals k times 1 over x. You want a good example? Where work is the constant, but how are power and time related? As time gets smaller, power gets bigger. It's an inverse relationship. How do I know? Because time's on the bottom and power's on the top on the left-hand side. Or if I bring in some circuitry, now we haven't done circuitry yet, but here you go. What would the area underneath this graph be? I've never given you this graph, but I almost always have someone who's able to figure it out. Let's see. Did I ask for a slope or an area? Area. So what am I going to do? Am I going to divide the units or times the units? So the first thing I would say is, well, maybe I know what ohms times amps is. I don't. So if the units don't work, let's try timesing the variables. I times R. Who remembers from Science 9 what I times R was? It's always someone who does. I'll throw it out there. Who remembers? It was Ohm's law, was what you called it in Science 9. Oh, boy. I know Mr. Vendiola covers it. He does a lot of circuitry, a lot of electricity. He actually lets you play with the toys and break them. It's the voltage. Remember V equals I times R? That was your big equation. Back then when you used the stupid triangle, hopefully I've showed you a much better formula manipulation method than the stupid triangle, right? I had some Physics 11 kids this year, and I started introducing distance to them, and I had one kid, are you going to give us a triangle? And I almost went ballistic. No! I'm going to show you far better than a triangle. Got to teach you how to do it all in your head. Okay? The last one you guys look at in Math 11, pre-calc and foundations. If y varies as x squared, or y equals kx squared, and this is, hey, the good old parabola from Math 11. You want a good example? Kinetic energy. If I graphed kinetic energy versus velocity, what's the equation for kinetic energy? You all know it from this unit. Half mv what? If I graph kinetic energy versus velocity, it would be a parabola, because it's a squared. Now, we're not going to do it much this year, but you'll do it a lot more next year. There's a mathematical trick called curve straightening. Curves are tough to deal with. Who's in calculus this year? So you're learning how much math had to be created by Sir Isaac Newton to deal with curves. You guys have done limits? Have you started derivatives? Just starting? Have you learned the shortcut yet? You have? Okay. Okay. It's a great shortcut. Anyways, one way that I could straighten this curve out so that it was a line instead of a curve is, instead of graphing energy versus velocity, I could graph energy versus velocity squared. If I did that, I'd actually get a straight line, which is easier to do math with if I don't have calculus. Hey, what would the slope of this graph be? Okay, how do I interpret, how do I figure out what they mean by slope? What did I tell you the trick was? Someone said the magic word begins with a D, yeah? Divide. First, I'll try the units. Joules over, oh, by the way, can you all look up right here? It should be meters squared per second squared, because V squared would be squaring all the units, yes? So it would be joules per meter squared per second squared. I don't recognize that. So if I can't recognize it from the units, I'll try dividing the variables. What's the variable on the y-axis? Kinetic energy, Ke. What's the variable on the x-axis? Hello? What's the variable? So, Ke over V squared. Do I have an equation that has kinetic energy and V squared in it? Do I have an equation on my formula sheet that has kinetic energy and V squared in it? I do. Really? You're having to look it up? Oh boy, a lot of you haven't done the homework. Ke equals a half m what? V squared. So you know what? The slope of this graph is half the mass. So if you wanted a nasty question that's actually really easy, and I saw this on a provincial one year, they gave people this graph with numbers on it, and instead of asking them what the slope was, they simply said, what was the mass of the object? And kids freaked. No, find the slope and double it, because the slope is half the mass. It's sitting right there, if I don't panic. So if it's slope divide the units or divide the variables, and you'll almost always, in fact, you will always be able to figure it out. If it's an area, even if it's a curve, times the units or times the variables, and you'll be able to find an equation that contains it and figure it out. So, to figure out what quantity is represented by slope, simply and to figure out what quantity is represented by area, simply multiply the units or the variables. Two very handy tricks in graphing. Do you guys look at graphs in Chem 12 as well? I suspect you might. If you do, I mean, you can memorize what they mean, but I'm telling you, you can usually figure it out from this. And you, hopefully you're hearing my distaste for memorizing things that I can figure out with 1 second of thinking. Lovely Foxtrot comic. Homework. This is wrong. Homework. And remember, I have an answer key for the ultimate review online, showing all my steps. Before you ask me any questions from the great big review, please try and figure it out yourself. Okay? Normally I have a couple of cool videos and things. I'm going to pause and I'm just going to say, take this time to get completely caught up on homework, especially Santa's Little Helpers, please. Especially Santa's Little Helpers. Especially Santa's Little Helper. Okay. Get caught up on the homework and start really preparing for your test.
When's your cutoff for